Good morning, good evening, good afternoon to all of you who joined us today from all over the world. My name is Devja. I'm a program manager on the Earth Outreach team, and I'm going to be your host for today's event. On behalf of the team, I'd like to welcome all of you to Hey Earth Engine, How Do I? Today is going to be a live streamed event, which means that we're here talking to you in real time. Today, we're really excited to have all of you here. It's going to be so much fun. And we're joined by experts from the Earth Engine team. Welcome, team. Okay, awesome. So before we introduce all of these awesome folks, let me walk you through how it's going to work today. When you registered for this event, you had a chance to pre-submit your questions for us. We got some really good questions from all of you, and we're going to start out today's event by answering some of them. If you didn't get a chance to submit your question yet, don't worry. You can do it right now by using the Ask a Question box below the video. So if you see a question in the Q&A that you really like, also be sure to upvote it by pressing the like button. And we'll try to take as many live questions as we can. We have Tyler here who will be monitoring the live Q&A throughout the event. So do not miss out on this golden opportunity to connect with Earth Engine experts. Speaking of experts, we have Michael, Justin, Nick, and Tyler here from the team. Welcome to the event, team. And I thought instead of doing traditional introductions, we could help the team practice getting into Q&A mode by starting off with some really fun icebreaker questions. So team, are you ready?
Ready.
Awesome. Okay, let's get started. Nick, the first question's for you. You're already quite famous for your training on machine learning with Earth Engine. So here's a challenging question for you. Do you have any predictions for when AI is going to take over the human race?
Yeah, thanks, Devja. What's interesting about that question to me is that if you assume that the AI can pass the Turing test before it achieves dominance, then it could have already happened, and we would never know because the AIs are communicating with us as if we're humans. So I think it's already happened.
Oh my God. So we're all controlled by bots. That's a haunting realization. Okay, moving on to something a little less eerie. Justin, and I'm sure a lot of you know him already. If not, this question can help you guess. Justin, if you were at a party, a socially distanced party, of course, which data set would you be most likely to talk about and why?
Yeah, far and away, I would talk about Landsat. I have a big love for Landsat. I'm fascinated by landscape change, and the length of the Landsat archive is unparalleled. And with relative ease, you can explore change for the last 38-ish years and almost 50 years if you're willing to work for it. Every pixel tells a story, everything from urbanization to wildfires and insect outbreaks and harvests. Our world is constantly changing, and Landsat is a great tool for being able to witness that and put it in context with history.
Thank you, Justin. Remind me to ask you that question at our next Earth Engine party. Okay, moving on to Michael. And this question probably gives away your role on the team. If you could be a programming language, Michael, which one would it be and why?
I feel like the obvious answer here has got to be the Earth Engine language that we use to code in the code editor. I would say that because the language is quirky, a little goofy like me, but ultimately effective. It's kind of a cheat though to say that. It's not really a language, it's more of a library. My favorite language has got to be OCaml. It's kind of a funky functional programming language that lets you mix paradigms a little bit. Yes, I think that does reveal my role as a software engineer on the team.
Awesome. Okay, so last but not the least, Tyler, and your question is also going to be topical to your focus area at Google. When you're out with a group of friends, and I don't know how often this happens, but the conversation turns to talk about water. Which body of water do you like to talk about first?
So I don't know if I'd call it a body of water, but my favorite type of water is the frozen stuff falling from the sky, particularly when there is a very high snow to water ratio. So did you hear about that storm this week in Colorado?
Oh my God, no, but it sounds scary. Oh, wow. Okay, well, I don't know how much fun you had answering those questions, but I definitely had a lot of fun asking those questions. Thank you, team, for playing along and coming up with such great answers. I mentioned earlier that we're going to be doing a mix of live and pre-submitted questions. This is a reminder to the audience that if you haven't had a chance to submit your question yet, now is the perfect time. So please do add your questions for the team. Okay, so now that we're all warmed up, let's get started. First question of the day was submitted by one of our participants, and I really hope that they're watching right now. Their question is, how can I see a value on my app when I click on a particular location? Michael, you've worked a fair bit on Earth Engine apps. Do you want to take this question?
Let's do it. So I have a code editor all warmed up and ready to go here. So this was a pre-submitted question, and in filtering through them, I left a comment on this that said, oh yeah, just use onClick and a reducer. It turns out that is all you need to do, but it'll be nice to unpack that a little bit. But if you leave with nothing else, onClick and a reducer. So here I have kind of a squished together code editor here just so we can see all the different pieces. I do want to call out that we have, if you're in the code editor, the question specifically asks about an app. But if you're talking about the code editor, we do have this inspector pane, which lets you click on a layer. Here I just have SRTM with a nice stretch. So let's go somewhere a little prettier. Where you can click and investigate interactively and see the values that are printed out here. This is both the objects and the underlying pixels. But I think the spirit of the question is, if I have this map displayed, how do I know what the pixels are if I'm in an Earth Engine app? So that's what I'll go ahead and try to code up real quick here. The mechanism, so Earth Engine apps, you only get sort of what's below the fold here. What's on the map itself or in the UI root pane. Here we can use labels. So this is UI label, and I'll just say this doesn't do anything by itself, but we can add it to the map. We can add our label, and that shows up just as a label on the map. This is the mechanism that we'll use. This is the place where we will update the results of doing inspection. So what does onClick mean? So that's the onClick callback for the map. So that is an event that's fired every time that the map is clicked. So if I'm not in this inspector, and I'll just pull this off to the side here. If I'm not in the inspector, when I click on the map, nothing happens by default, but there is this map.onClick callback that I can register. And what a callback is basically just a function that I can provide, and it receives some parameters. So in this case, what it receives is an object with keys, longitude, and latitude. So first thing maybe we'll want to do is have a function that updates the label. Update label. And this will take just a JavaScript object. And this is an important distinction to draw. It's not a regular object, it's a JavaScript object. So this is something that exists in the client, and it's not an Earth Engine server-side function. If you're confused about the distinction there or want to find out more, we have documentation available in the docs, the user guide up here. What we can do though is here label set value to be JS object. And let's even call this, let's give it a prefix. We can use here, you'll see I'm using the JavaScript string concatenation, so this plus. Usually in Earth Engine, you have to use .add or .cat in order to stitch things together. Here, because this is a JavaScript object and a JavaScript string, we can use them together. So this function is pretty unexciting. I can call it. It really doesn't matter what I call in there. And all that did was update the value. Further, we can construct a function that can actually receive a map callback. So let's call it update label, or even better, onClick. And what this will receive, like we saw earlier, is an object with latitude and longitude. So we'll call that click. And let's just for now create a point. So ultimately what we want to do, I'll explain just the overall shape before I write the rest of the code. When we click, this function will be called, and the parameters are going, this click object will have a latitude and a longitude. We can use that latitude and longitude with image.sample, which is a function that will let us specify a region. So we'll just create a point, and we will just sample the pixel at that point, and we'll update the value of the label. So there's just some juggling, but that's really all that's happening. This is the point. So I create my geometry point, and I get click.longitude first. So this is the point that was clicked. And I have my image, so that image from line 1, sample, point. And what do I want to do after that? Really, I just want to update the label. I can't just call update label with sample because it expects a JavaScript object. What I want to do is sample evaluate, and all this is doing is saying, take the sample, compute, go to the server, fetch the value, and then whenever you get a JavaScript result, pass that into the further function. So update label. Before we can kick this off and try it, let's first wire everything together. So map.onClick, this is the callback function, click callback. And this should work. Let's try it and see. We'll open up the console just so we can see any errors. So we are getting prefix, object, object. Why is that happening? So this update label function should be accepting a prefix here. Sorry, it should be accepting the evaluated sample. We are, why are we doing this? 1 second. Yes, of course. So the sample here returns a feature collection. Sorry, got mixed up. We can, just for the sanity checking, really click and print halfway through here. So this is a good exercise in debugging. This is returning a feature collection. And what we actually want to do is extract the first feature from the first collection and the property elevation from that feature. So we went all the way down the stack. So instead of passing that through, what we want to do is say sample dot first. So this is a feature collection. We're getting the first feature, and then get the elevation. Okay, so I'll rerun this, and I'll click, and you'll see we're getting values from the map wired through. I'm just going to do some quick cleanup here. Click to see, click to inspect, we'll say. And you'll see that we have a nice wired up inspector. And so this is 20-ish lines of code. We can continue to refine this and polish and say, for example, style of a map to have a different cursor. So here we have this hand. I don't know if you probably can't see that on my screen, but we can set the cursor styling to crosshair, and that just makes it behave a little bit more like the inspector. Hopefully this is helpful. I'll provide a link to this so that folks don't have to type all of these words out. Yeah, that's how you create an inspector for an app. So even if I don't have any of the code editor UI, I can interact with the pixels that are underlying my code.
Thank you so much, Michael. I'm sure the person who asked this question found it super useful. Okay, so our next question is also pre-submitted. The question is, hey Earth Engine, I figured out how to visualize stuff. How can I query for information? For instance, if I have a visualization of NDVI, how can I find the coordinates of the point with the highest NDVI value in a given region? Justin, I'm going to put you on the spot and see if you can answer this.
Sure. So in general, if you want information about pixels across the region or through time, Earth Engine has a, excuse me, a set of reducers. So that's what we'll do here. First, we need an image. I'm going to use Modus NDVI in this case. And I'll just do a search for Modus NDVI. We've got a couple options here. I'm going to go with this one here. And I just need to get the collection ID, and I want to see what bands we have. We have NDVI, and I can see that it's scaled by 10,000. So let's get this imported. And I just want to work with the first image that's in the collection. And I want to select that NDVI band. And then let's just take a look at what it is. And I'm going to visualize it. We'll do a min of 0 and a max of 10,000. Remember that we've scaled, this data set is scaled by 10,000. Usually NDVI is -1 to 1. And we'll color it on a gradient from white to green. What do we got here?
Reload.
Yeah. All right. Here we go. All right, and then let's find a place to investigate. Let's see. I want to find a spot that's got an obviously high value. Let's try this area here. There's a few high values. And I'm going to be looking for a lat and longitude value of the max NDVI. And since latitude and longitude is not in this, Modus has a sinusoidal projection. So I'm going to just reproject this so everything looks a little bit better. You have to be careful with reproject, though. Make sure you're zoomed in pretty far. Otherwise, bad things can maybe happen. All right, so these two pictures here, my guess is the one on the left is maybe the highest. So we're going to hope that our algorithm finds that. And so let's get a region on here. And first, let's just find the maximum value in that region. I actually called this column, but it's an image. Now we do reduce region. And we need a reducer. Let's do the max. We already have our geometry from the imports. We'll do scale of 500, and the rest we will leave as default. And then print it. Print in the console. Oh. An object back, NDVI 500, or excuse me, 5,000. Again, scaled by 10,000. So we don't yet know the lat and long. We know that it's, that's the maximum value in this region somewhere. In order to get lat and long, we can add latitude and longitude bands to this image. So I'll do that next. And there's an image method to add pixel long lat, and see what that looks like. Now we've added these bands. Previously, we only had NDVI. Now we have longitude and latitude. So when we do the reduction, we will also be able to include longitude and latitude. So we'll copy this max reduction again. But there's an important point here to make is that the max reducer will independently identify the maximum value in the region per band. But that's not what we want. We want to find the maximum value of NDVI and then its corresponding values for longitude and latitude. So to do that, Max has a parameter where you can provide the number of inputs. And so what I'm going to do is provide all of the bands as inputs. There's three bands. I'm going to pull these out as a variable because I'm going to use the band names later. And we'll give it to this, and we'll ask for its size. And print the results. And we can see that now we have longitude and latitude. I don't like the labels, though, so I'm going to relabel it to have the original band names. And so this is a dictionary, and there's a rename property, or excuse me, method that takes the old or the existing the keys here, and we'll replace them with the band names from the image. All right, so now we have latitude and longitude sort of labeled correctly. And now let's just put a geometry based on these latitude and longitudes onto the map. So we have to get these values out into a geometry object. Max NDVI, we'll call it location. Point. And this is a dictionary, so we can get the values out by their key name. And then we'll add it to the map. And cross our fingers. So this is interesting. We can see that it's a little bit offset from the center of these pixels. And I believe that is because our reducer, we have not defined the CRS. So it's using some default. So let's see if we can fix that. CRS comes after scale. Okay. And we want to make sure that it's the same CRS that we were using on the map, which is WGS84. There we go. So now we have identified the latitude and longitude of the pixel with the greatest NDVI value, and we can overlay a point indicator. That's that.
Awesome. Thank you, Justin, for introducing us to reducers. Okay, so now we're going to switch it up. The next question is from the audience. It's a live question. The question is, how can we do weight optimization in Earth Engine using a simple method such as Bayesian optimization? Nick, the machine learning expert, do you want to take this?
Yes. I am no machine learning expert. I will only say that I don't know anything about Bayesian optimization, but there's a paper that was done by an Earth Engine user named Jeff Cardile, which is all about Bayesian updating in Earth Engine. And I would point you to this paper. I think Tyler is going to put the link to this in the chat. There may even be code in this paper, but I'm sure that if you ask Jeff nicely, he might be willing to share his method with you. So I will point the person asking this question to this paper and to follow up with the authors with any further questions. I will also note that the Earth Engine community is a great resource for asking, for getting answers to these kind of questions, and you can search the developers list, and of course, you can use Google Bayesian updating in Earth Engine. That might lead you here as well.
Thank you, Nick. We definitely want to encourage our audience to use the community more. And this is a great way to demonstrate that. Next question is pre-submitted. The question is, hello, my output is not exporting. Even if it does, it's just showing blank on ArcGIS. It makes sense. We let you off the hook easy on that last one. Can you have debug this one for us?
Yeah, sure. Let me just go to my screen here. So let's start from scratch here. This is something that we used to discuss in our trainings, and it's worth talking about it a little bit here. I'm just going to grab a cloud masking example here. So if you go to examples in the code editor, cloud masking, and I just went to Landsat 8 surface reflectance, and I'll just go to a place that I know pretty well, which is San Francisco. So I just searched the place and then went there. And now I'm going to click run on this example. And you get this nice cloud-free composite here that you might want to export. And so what you want to do is you want to say export.image.to somewhere, and let's just say to drive, open parenthesis, control space to get the list of parameters here. Let me just get a little bit more screen real estate here. So there are all the parameters. We don't need all those, so I'm just going to start filling them in. The image that you want to export is that composite, and the description can be whatever you want. We'll just call it demo. I don't think we need any of this. We do need a region though, and so let's just make a small region we can use here like that, and export that, or sorry, exit that geometry is now sitting in our imports, and I can specify that. Geometry, there we go. Always specify scale when you're exporting.
Nick, could you zoom in a little bit?
About that. Is that better?
Yes, could you just zoom in a little more?
Yes.
Okay,
that.
Perfect.
All right.
Thank you. Yeah.
Okay, so we're exporting, always specify scale. This is scale in meters. I am just going to skip the rest of this. I don't think we need it. And that, let's just try running it and see what happens. And okay, there's a task that's going to run. What is this going to give you? This will give you this composite with all its bands in whatever their current pixel type is. which may or may not be what you want. So if you get a 10-band image that has float 32 pixels into, say, whatever your software of choice for visualizing is, this may not look like what you're seeing on the map here. And that's a common source of confusion. So you either have to know how to stretch this in your software of choice, or you can export what we call a visualization image. And here's how you do that. I'll just say var visualization equals this composite dot visualize. And the arguments to visualize are the same arguments that you'd give to map.add there. So I can just take these visualization parameters, post those right in there, and now we can check whether this is going to do what we want by adding it to the map without any visualization parameters. So I can just add this, and take that away. No visualization parameters, and we'll just call it what it is, and run it. And now what you should see on the map is first the cloud-free composite, and then the visualization, which should look exactly the same. So if you can add this to the map without any visualization parameters and have it look the same, then that visualization has worked. And now you can export the visualization image. And so I'll just take that and put that there, and we'll call this something else. Visualization. And what you will get from this export is a 3-band 8-bit image that looks like what you see on screen here and is easy to visualize in other softwares. Typically, image processing softwares or display softwares know how to show you this kind of image, this 3-band 8-bit RGB image. So for example, if you look at this in Drive, you'll see that you can, this image will look like this, and this image will look like nothing. Drive doesn't know how to display it because it's too many bands and it's this strange data type. So that is the sort of the short answer to exporting stuff. You can export data, in which case you have to figure out how to visualize it in its destination, or you can export the visualization itself, and that should be easier to see. So that's the answer to that question. I think there is another question about sort of projections, native projection and scale, which is another nuance here. You should definitely specify that. I don't know who's going to answer that question. Justin, maybe? Next? Anyway. Next.
Yeah, thanks for that segue, Nick. Exporting seems to be a big theme. Our next question is a live question, which is exactly what you talked about. When exporting images to Drive, is there a way to export it in the native resolution and projection of the data set instead of specifying resolution? Justin, do you want to take this?
Sure. So I've started coding this up already. So what I've done here is I've imported a Landsat collection. I have filtered it by this bounds here, which for this demonstration, I want to be able to include multiple granules, path row tiles. And then I have filtered it to looks like 2 months worth of data in 2019. And every image in the catalog has a native resolution and projection. And so this first chunk of code here is just demonstrating that. So from this collection, I've just selected the first image and the first band. And then I'm using the projection method to find out some projection information about this first image in the collection. And that is what we see here. I can see that it is a UTM, pretty specific, kind of projection to this region on Earth. And I can see that the pixel size is 30 by 30. based on the CRS transform. So you can use, you can also then get the nominal scale. You can pull the scale value right out of the image's projection information. That's what I've printed here. So if you wanted to do the native resolution of an image, here's the export chunk. What you can do is you've got your image. Excuse me, here you've got your image. And then you can, here, let me put all this in here. You export your image, you get the projection from it, and then you pull out the nominal scale. And that is one way you can define the native scale. But I want to make an important note, and Nick mentioned it previously, is that basically you always want to specify the scale non-programmatically, probably, because if you are, for instance, making a mosaic of multiple images that have different projections, like in this case right now, we probably have a few different UTM projections in this region. And so I've coded that up here. I've made a mosaic of this collection, selected the first band, gotten the projection. And if we print it, we can see that in the mosaic, and now instead of being in the native UTM reference system, we are in WGS84 G-graphic. And that means that all of the pixels are in degrees, and we can see that the native resolution of this computed object is 1 degree by 1 degree. So if you were to use like nominal scale in this export now, it's no longer 30 meters. And so it's best to always define this manually, depending on what your data type is. You should do some exploring and know what the resolution is and specify it manually.
I just like to tack on, it is, in my experience, it's always easiest to export very explicitly using a CRS and CRS transform along with dimensions. So being able to really tightly say, this is the exact set of dimensions that I want in this exact CRS and transform. Because Earth Engine lets you specify images with multiple bands, and those bands can have different projections, resolutions, everything, even footprints. I find it best to be super explicit at the point that you're exporting, if you really want to match a particular grid. If you look, could we switch to my screen really quick? If you print an image, you'll see for each of the bands here, I just have SRTM that I've imported. You can look at each of the bands, and those bands will have, just like Justin was showing, the projection information, but they'll also have dimensions and CRS transform and CRS. So you can really dial in exactly, give me this particular grid to match a particular band. Yeah, that's just tacking that.
Michael, while you're there, there is another question. Exporting is really our popular theme of the day. This is a pre-submitted question. How can I automatically run an Earth Engine script and export the results to Google Drive? Can you take this one?
Yeah, I have a preloaded tab talking about installing the Python client. So the short answer is there's not an easy way to do this automatically. We don't have anything built into Earth Engine that will say once a week, once a month, once a day, etc., like run a particular command. So that's something you have to construct yourself and implement in some other environment, where you manage the calls to Earth Engine. What that winds up looking like in practice, and I'd really appreciate if other folks jumped in too, what that looks like in practice, we've seen folks do that on their own machines. So, if it's not a highly, if the job is not critical to have, at a particular cadence, you can just run it on your laptop, have it set up as a cron job or a reminder in your calendar if you're really primitive. The more sophisticated options are running it in a dedicated environment. So something like a Google Cloud container. There's also, I think it's called Cloud Functions, which will trigger based on certain conditions. Those are, it also doesn't have to necessarily be in Google environments. If you have, for example, a container on Amazon or with Azure or something, any of those, if you install the Python client library, the Earth Engine client library, or the Node Earth Engine client library, those will let you construct the expressions that then you can pass and run your exports.
Okay, thank you, Michael. Moving on from exporting, the next question is, how do I create time series charts? I get errors every time regarding system time_start. I feel like this is a question that quite a few participants might have. Justin, can you take this one?
Sure. I'm going to go back to Modus again. Modus works really well for examples. It's clean, nice, clean data. And what I want is, let's do surface reflectance. And again, I'm just going to get the image collection ID. And I'm going to want to calculate NDVI for this example. And so it looks like I need bands 1 and 2 red and near infrared. So I just want to make a note about the bands. So again, I go var, import my collection. And we're going to work with the time series. There's a lot of Modus data, and I don't want to, show it all. So we can be a little quicker here. So I'm going to limit it to just the first 100 observations. And I'll select out just the first 2 bands. And charting in Earth Engine time series is extremely easy. There's built-in functions to handle image collection data. And so let's just take a quick look at a chart by default. It's under UI chart, we've got an image collection, and we'll do a series. Import a collection. We need a region. Let's just do somewhere in California. By default, it's a mean reducer. The scale will be the native scale of the data. And the X property by default is the system time property of the system time start property of the image. And this is important. Let me just show that before I do anything else. I'm just going to print the first image so we can look at its metadata. So every image coming from the data catalog has this system property time start, which is milliseconds from, I think it's January 1st, 1970. And the time series charting functions by default need to have, it's going to be looking for this value. So it's important that the images include this. And it does, we see that it does. So we should be able to make this chart and be able to see it. There we go. So we can see that it's labeled by system time start on the x-axis and band values on the y-axis, the mean within that region that we've defined. But there's a lot of ways that you can lose this property, this system time start property. Anytime, I guess maybe Michael can help specify, but anytime that you are generating a computed object, a computed image, it can't be assumed that a system time property should be copied over to the derived image, and so it's not given a system time property. So I can demonstrate that with NDVI if we just make a quick function.
While Justin is typing there, let me just add that the value that is in system time start should be epoch time in milliseconds. If you put a date in there, when Earth Engine goes to look for system time start, it might get confused. So if you're going to populate your own system time start field or change it, make sure that it's in milliseconds.
Thanks, Nick. So now I'm going to apply this NDVI calculation function to the whole collection, and I'm going to print just the first result, the first image. Oh, okay, so it wants to know the band names. Let's see. All right, so now we have this derived NDVI image, normalized difference, and we can see that there is no system time start property. So if we were now to chart this new collection of NDVI images, we should get an error because it by default looking for a system time start property, but it doesn't exist. Right. So I'm just assuming that that's the problem that this person is having. It's a really common problem that you need to include the system time start property. And so we have lost it in our calculation of NDVI. We've taken our image and we've derived NDVI from it. And it seems like, well, it's the same image. We should have a system time start property. But Earth Engine can't assume that, that's still valid. So we need to manually add that onto this image. But that's easy to do. Luckily, we can copy properties from an image onto this output with copy properties. It needs the source image. So we'll take our input image and we'll tell it what properties from that source image we want copied over. And we say system time start. And now you'll see the NDVI plotted because there is this system time start property. So it's always good practice to be copying over properties from your derived image. I often will copy the whole shebang. If you can do image.property names, and that will give you all of the properties from the sourced image into the derived image. That's that.
Awesome. Thank you, Justin. Okay, so we're going to make the next two questions a little fun. Michael, I'm going to put you on the spot, and let's see if you can answer both questions in 120 seconds or under. You have 120 seconds for both questions. Okay, so the first question is, would it be possible to use Python libraries like scikit-image in Earth Engine? And the second question is, how can we use Earth Engine commercially? Okay, your time starts now.
I would love to get a timer on the screen. We'll fix it in post. The first one maybe takes a bit longer. I'll answer the second one. Earth Engine commercial usage, you can reach out to earthengine-commercial@google.com. It's not broadly available for commercial use, but we are testing out new commercial use cases. The API docs have much more information, so check that out. But earthengine-commercial@google.com. the first question is, can we use, for example, like scikit-learn? The broad answer is no. You can use them with Earth Engine, but you can't use them in Earth Engine. So Earth Engine's computational infrastructure is built on Google's like internal data center compute. So we farm out computations to many different computers, and we have built-in logic for parallelizing and optimizing and making sure that queries run quickly and reliably. The problem with third-party libraries is we don't really, they don't fit into that paradigm of computing. So the way that you can use those libraries with Earth Engine is really to do your computation in Earth Engine, do pre-processing in Earth Engine, fetch the data, dump it to a cloud bucket or Google Drive, do some processing, and then return it potentially to Earth Engine, or maybe that's where you're finished with it. How am I doing on time, David?
I think you finished just in time, maybe 5 seconds here or there.
Perfect.
But great job, Michael. Okay, so this one's a live question. Would it be possible to combine temporal segmentation results, example from LandTrender, CCDC, and CodeEd, and add them into a classifier, example random forest, to improve forest disturbance predictions? Okay, who wants to take this one?
I can take that one. I worked with LandTrender for a long time.
Awesome.
The question's a little bit broad. It sort of really depends on what you're trying to model and predict. But in general, the outputs of these algorithms are images, and so they'll go into a classifier like any other bands that you would include. I guess some of the advantages are that segmented, spectral data from LandTrender and CCDC, it has been sort of smoothed out, and so it provides often a more stable time series of imagery. If you're classifying, for instance, your example is on disturbance, but if you were classifying land cover, for instance, you would expect that it would not bounce in and out of classes as much because you have such smooth time series. With regard to disturbance, these algorithms are also outputting information about segments, a spectral temporal segment that has a start and an end date, and often the delta, whether over that period of time some spectral index was either going up or going down. And those bits of information can be helpful in determining maybe a disturbance agent or when a disturbance began and ended. There's also really good documentation. Maybe we can share in some resource data for both LandTrender and for CCDC, sort of independent of the Earth Engine guides, but that are really helpful in understanding the outputs, which might help you wrangle them into the kinds of predictions you want to make.
Thank you, Justin. So quick tip, please check out the Earth Engine docs. They're a super helpful resource. We're down to our last questions for today. The next question is, how do I get started with TensorFlow models? They would like to get, the person who asked this question would like to get a better understanding of when to use TensorFlow models versus the models available in Earth Engine. Nick, I assume you can take this one.
Yeah. Let me just go to the docs here because I think you'll find what you need in the docs. Here are docs, developers.google.com/earth-engine. There's a ton of stuff in here. For example, in the tutorial, the Earth Engine API tutorial, you'll find the answer to the previous question that I did, which is how to export visualization images. You will also find in the
Nick, could you zoom in a little? Sorry.
You will also find
perfect.
In the machine learning section a whole page about TensorFlow models, and specifically, you will find a page in there that describes when you might want to go to a TensorFlow model. I'm not sure why this link is not working here. Let me just try something here. There we go. Okay, so, oh, sorry. It's actually overview of ML and Earth Engine. Sorry, it's being slow here. Sorry, I don't know why this is taking so long. Okay, here we go. This is what I was after. This is sort of a little rule that lets you decide when your data set gets too big for the Earth Engine classifiers. And specifically, N is the number of data points, B is the number of bands. When it gets much larger than this, you probably want to start thinking about using TensorFlow models. There are a bunch of examples on these pages here for doing that. But the important thing is that if you are doing something with a big model or lots of training data and it's taking a very long time to train, you might want to do that in TensorFlow, because Earth Engine, you'll have timeouts and that kind of thing. So that's a good reason to go to TensorFlow, is when your data gets very large or your model gets very complex. I think I can say this, Michael, correct me if I get something wrong here. The classifiers are being updated, the Earth Engine classifiers, such that in the future you'll be able to handle larger data sets. But for now, when your data gets large, you probably want to go to TensorFlow.
Thank you, Nick. Okay, so we have 3 minutes on the clock, and I'm assuming one last question. Michael, are you ready to do a quick 60-second sprint again? Let's see. Okay, so the question is, when exporting images to Drive, is there a way to export very large numbers of non-overlapping images in one go instead of running them as separate exports in the Tasks tab?
The fastest way I can imagine doing that is just to, because they're non-overlapping, condense all the images, mosaic all the images together, image collection.mosaic, and that will flatten all the images into a single image, which lets you run as a single task. We don't currently have support for image collection export proper, so we don't have a mechanism for you to say, dump all of these images as separate files. It's something we are working on, but we don't have any concrete timeline for when that'll be ready.
Awesome. Okay, so we're at the end of our session for today. We hope all of you who are joining us live enjoyed this event and that the space was useful for you to get your questions answered. We really apologize if we couldn't get to all the questions. We tried to answer as many as we could, but if you are still facing trouble with your scripts or still have questions, please go to our help page on the Earth Engine developers site. Tyler will post a link in the Gather Q&A. But it's a useful resource which will point you to the forum, the GIS Stack Exchange, and also all the documentation that you need to go through. A big thank you to the team for doing this and for taking out the time to code live, to answer all sorts of fun questions. And thank you to everyone who joined us. A special shout out to the Earth Engine community, who've also been super active, as Tyler told me, answering some of the questions live. So a huge thank you to all of our community experts. We feel like they probably even know more than us. We hope to see you again soon. Please don't forget to sign up for our future events. Once again, a big thank you from the team. Take care, everyone.
Thank you.